Good morning, children. Today we are going to study about electrochemistry, which is your chapter 3, and in this part 1 presentation we will study about the electrochemical cells, that is galvanic cell and electrode potential. Now these are the answers of chapter 2 solutions, part 6. Verify your answers from the answers which I have given over here. Electrochemical cells. Now electrochemical cells convert chemical energy to electrical energy or vice versa, and they are of two types. Number 1, galvanic cell, and number 2, electrolytic cells. As far as galvanic cell or voltaic cell is concerned, well, it is a device in which the chemical energy is converted to electrical energy due to a redox reaction taking place in it. The electrode at which oxidation occurs is your anode, which has a negative polarity, and the one where reduction takes place is cathode, which has a positive polarity. Now a galvanic cell consists of two half cells, and these are electrically connected together by a salt bridge. The left half cell is the anode where oxidation occurs and consists of a zinc rod dipped in 1m zinc sulfate solution. Here zinc atoms lose electrons to get oxidized to zinc ions. Look at the equation. Zn solid is getting converted to zinc ions aqueous by losing 2 electrons. The electrons so released, they will flow through the external circuit and reach the copper rod, which acts as the cathode. Now the right half cell is your cathode where reduction occurs. It consists of a copper rod dipped in 1m copper sulfate solution. Here copper ions in the solution accept the incoming electrons and get reduced to copper atoms, which deposits on the copper rod. The equation you can see, Cu2 plus ions are gaining 2 electrons and forming copper solid. Now adding equations 1 and 2, we will get the cell reaction, which is zinc solid plus copper ions in aqueous solution gives zinc ions in aqueous solution plus copper solid. The cell notation is represented as follows. Now in this equation, the left half represents the oxidation and the right half represents the reduction. In the left half, you can see zinc solid is converting to zinc ions by losing electron in 1m solution. The double bar in the center represents the salt bridge, and on to the right we are showing reduction where copper ions in aqueous solution 1m are gaining electrons to form copper solid. Now this is how a galvanic cell looks like, having two half cells. Left half has a zinc rod dipped in 1m zinc sulfate solution. Oxidation occurs here. Right half has copper rod dipped in 1m copper sulfate solution. Reduction occurs over here. The two half cells are electrically connected together by a salt bridge and externally by a wire which is attached to a key and ammeter or voltmeter. A salt bridge is a U-shaped glass tube filled with a concentrated solution of an inert electrolyte like KCl, KNO3, etc., or their solidified solution in agar-agar and gelatin. The function of salt bridge is that it completes the electrical circuit by allowing the ions to flow from one half cell to another half cell, and number 2, it maintains the electrical neutrality of the solution present in the two half cells. So finally we can say the redox reaction thus obtained is responsible for the generation of electric current by a galvanic cell. Next we come on to electrode potential. It is the tendency of an electrode to lose or gain electrons when it is in contact with its own ions in solution. Now two cases we have to read over here. Number 1, when the metal atom present on the electrode M gets oxidized into metal ions with N plus charge by losing N number of electrons, the metal ions enter the solution and the electrons get accumulated at the electrode, giving it a negative potential, and we call this as oxidation potential, represented as E metal to metal ion. The electrode is called as the oxidation electrode. You can see the equation. Metal solid is forming metal ions with N plus charge by losing N number of electrons. Number 2, when the metal ion gains N number of electrons from the electrode, it is reduced into metal atom M. Now here you see the metal ions with N plus charge are gaining N number of electrons to form metal solid. So here a positive potential develops on the electrode called reduction potential, represented as E, metal ion to metal. The electrode is called as the reduction electrode. Now here you see the three types of electrode: null, oxidation and reduction electrode. In null electrode, no oxidation or reduction takes place because neither the metal atom nor the ion undergoes any change. The other two are oxidation and reduction electrodes, about which I have already explained you. Factors affecting electrode potential. Number 1, nature of metal and its ions. For example, zinc develops a oxidation potential by losing electrons, and copper develops a reduction potential by gaining electrons, as we have seen in case of galvanic cell. Second is the concentration of ions in the solution. Well, ideally you should keep the concentration of ions as 1m, the concentration of metal ions as 1m. But if there is any increase in the concentration of metal ions other than 1m, then that is going to adversely affect the electrode potential. And lastly, the third factor is temperature. This too affects electrode potential. Now coming to the exercise, you attempt the following questions given on pages 201, 205 and 207. I hope you all have understood the lesson today. Thank you. Have a good day.